Today we're going to be introducing organic chemistry. So organic chemistry is the study of carbon, specifically how carbon interacts with hydrogen, oxygen, or nitrogen, but there could be other elements in there as well. So some generalizations about organic compounds. They're mainly nonpolar. There's a reason for that. Their ENDs are very close to zero. In other words, carbon and hydrogen are like 2.2 and 2.4, so they're very close to each other. And so it's almost zero, and the molecules tend to be symmetrical. Now that doesn't mean there can't be polar organic molecules. As a matter of fact, there is a whole bunch of them, but in general we say hydrocarbons or organic compounds tend to be nonpolar. They are soluble in other nonpolar solvents like oil. That's our like dissolves like saying, which we will learn about a little bit later in the year. And they are non-electrolytes. In other words, they do not conduct electricity when dissolved in water, except for organic acids. Again, we'll learn more about that when we get to our acid unit. And they have low melting points. Now, to review carbon, even though we shouldn't really have to, but carbon has 4 valence electrons. Therefore, it makes 4 bonds to satisfy the octet rule. And it is a tetrahedral shape when it does that, although when they get bigger than a single atom, then they're not tetrahedral anymore, and we don't really learn the names of their shapes at that point. There are 3 ways to draw organic compounds. You can draw them as a molecular formula, which shows just the elements and how many of them there are, like C3H8 is an example. You can do the structural formula, which has the full structure drawn to the octet rule. In other words, everybody wants to have 8 valence electrons except for hydrogen or the regular exceptions. So it would look like this. Ignore the 1, 2, 3. That's actually for the next one. Or you could do the condensed formula, which is much more common. And so the way that works is you number the carbons left to right, so carbon 1, carbon 2, carbon 3, and then you condense the hydrogen that are attached to it. And it can be actually other things can be condensed other than hydrogen, but at this level we almost never do that. So for example, carbon 1 has 3 H's directly connected, so I say CH3. Carbon 2 has 2 H's directly connected, so CH2, and carbon 3, again, 3 H's, so CH3. Now, it'll never be written like this with the 1, 2, 3 in red. It would just be drawn like this, CH3, CH2, CH3, and then you would be expected to uncondense it and understand that this would be the structure and that this could be the molecular. Now, the next thing we're going to do is what's called hydrocarbons. So for hydrocarbons, they are just H and C only. There's nothing else in them. Otherwise, they wouldn't be called a hydrocarbon. There are 3 types. There's the alkanes, the alkenes, and the alkynes. And depending on their last name, it tells you how many bonds are in them. If you can guess from the picture, an alkane means that the carbon-carbon bonds are singles. In an alkene, the carbon-to-carbon bonds are doubles. At least one of them are doubles. And in an alkyne, at least one carbon-to-carbon bond is a triple. Notice I'm saying at least one, because one double bond makes an alkane, and one triple bond makes an alkane, an alkyne, depending on, it doesn't matter how large the molecule is. As soon as you have one double or one triple, it fits into those categories. Now, this information actually is on page 7 of your reference table. It's right down here. So you've got your ane, your ene, your yne. Those are the endings. Ignore the 2 things in the middle. We'll get back to them. And then you've got the structures here. And if you look at the name and the structure, you should be able to figure it out. Ane, single bond, ene, double bond, yne, triple bond. And it's that simple. All right, next we're going to talk about the general formulas and how to use them. So the name for table Q in your reference table is called the homologous series of hydrocarbons. So you're going to highlight that. All right, that's an important name, not because the name itself has any real significance, but because a lot of times what you'll hear is on like a Regents, they will reference table Q. Instead of saying according to table Q, they'll say according to the homologous series of hydrocarbons, and then you'll have students be like, the what now? And they don't realize that that's the name of the table Q. So it is right here as well. It's highlighted. So be careful. They like to play word games with that, where they'll reference this by name, whereas all the other tables they'll just say, you know, table G, table F, table P. Like they'll just reference the table number. That one, I don't know why, but they love to spell the name out. And then it says at the bottom on table Q in blue, N represents the number of carbons. I have it written here as well. I can highlight that in blue here, where N is the number of carbons. And the N is for the formula. So your general formula for the alkanes, so these guys are alkanes. So the general formulas are right there. They're also found on table Q, listed in order, right? So for C3, N is the number of carbons. So that would mean that I would have 3 carbons, so it would be C3. And then I would just make N3 and do the math. 2 times 3 plus 2, I end up getting H8. That's my general formula for an alkane with 3 carbons. If it were a alkene with 3 carbons, then it would be C3H6, because 3 there, and then 2 times 3 makes 6. And if it was an alkyne with that amount, it would be C3H4. So there's your alkanes, alkenes, and alkynes. I'll do a few more. And if you notice the pattern, once you have the alkane, you just take 2 away for the alkene, because again, that's how you gain the double bond. You lose 2 hydrogen. And then for the alkyne, you just take 2 more hydrogen away and you gain the triple bond in its place. And so that's what's happening. They lose 2 each time you go down. So I'm just doing the math in my head, but you get the idea. Now, a alkane is considered a saturated hydrocarbon. So what that means is it has the maximum number of single bonds. That's why it's an alkane. You've probably heard the word saturated in terms of saturated fat. Well, that's exactly what a saturated fat is. It's a fat molecule that has all single bonds, whereas an unsaturated fat has less than the maximum number of bonds. That's a fancy way of saying that it has a double or triple bond. That's literally all that means, all right? So now we're gonna get to naming. So in order to do naming, I'm actually going to, I'll pick naming up on the next video because I wanna go right into the next page and do the names that way.